solving inequalities with variables on both sides. Sometimes an inequality will have a variable on both sides of the inequality sign, so a solution is found by solving those inequalities. And so we solve them just like we would solve an equation with an equal sign. So if you look at this first problem, we're going to add 5x to both sides. So we have 7x plus 7 is greater than 21. And then this is just a two-step inequality that we can solve, so minus 7. And so 7x is greater than 14. Last step, divide by 7. And so when we do that, we get x is greater than 2. Here's a second example with fractions. Remember, you can get rid of fractions by multiplying everything by a common denominator. So I'm going to use 16 as my common denominator here and multiply everything by 16 so that I no longer have fractions to deal with. So when I do that, the 16s here cancel out and I get a minus 9. Here the 16s cancel out and I get 2b. And then I have my sign, greater than or equal to. Here the 16 cancel out and I get plus 5. And here the 16s cancel out and I get negative 10b. And so now I have an equation just like the last one where I have variables on both sides. So I'm going to get rid of one of them. So I'm going to minus 2b. And so I have negative 12b. And then I'm going to minus 5 from both sides equals negative 14. And so last step, divide by negative 12. And so b equals, oh, I'm sorry, I just wrote the equal sign. Don't forget to write the correct sign in here, which is greater than or equal to. So b is greater than or equal to 7 over 6, or 7/6. Sometimes we need to do some distributive property before we solve a problem. So these problems are really 5-step problems then. They have distributive property, which we'll do first. So 2x minus 16 minus 3x is greater than 6 minus 6x minus 12. And again, I got that negative 3 times 2x and negative 3 times 4, and 2x, 2 times x, and 2 times negative 8. And then we can gather some like terms. 2x minus 3x is negative 1x minus 16 is greater than, and we can do some adding like terms on this side as well. 6 minus 12 is negative 6 minus 6x. And then I have variables on both sides, so I'm going to add 6x. And so I get 5x. And then I'm going to do the next step, which is add 16 as well. So 16 and negative 6 gives us a 10. So 5x is greater than 10. And so you should be able to start doing those 2 steps at once. If you can't, just do them one at a time and follow the process through. And then the last step here is divide both sides by 5. So x is greater than 2. Inequalities can sometimes be true, always true, or never true. In other words, false. An inequality or equation that is always true is called an identity. A contradiction is an inequality or equation that's never true or that's false. So there's some special cases that we're going to look at here and determine whether it's true, sometimes true, always true, or never true. And if it is sometimes true, then we have to identify the solution set. And the solution set is just a set of values. So a set of values that make it true. So there's some things that will make it true and others that won't. So let's solve this inequality. So the first thing I'm going to do is add like terms. So 3x minus 2x is 2x plus 4 is greater than 2x plus 7. And some of you should recognize right away that there's going to be a problem because we have a 2x on both sides. So when we minus 2x, then we get 4 is greater than 7. And is 4 greater than 7? No. So this is false. So this is never true. Okay, so if you have some number and you get it to be false, then we know that it can never be true. If you get some number here, like if we had gotten 8 is greater than 7, then we would know that that is always true. And so that's the identity, is when it's always true. And then we have ones that are sometimes true, like if we look at the problem above here, we got x is greater than 2, so that one's sometimes true. It's true when x is greater than 2. So let's try this last problem here. And so we need to do some distributive property. So 3 times 2y is 6y, minus 3 times 6, which is 18, which is less than or equal to 6y plus 4. And so again, you should recognize that we have a problem because we have 6 y's on both sides. And so we minus those, we're going to get negative 18 is less than or equal to 4. And is negative 18 less than or equal to 4? That's true. And so that's always true. Negative 18 will never be greater than 4. And so that's an always true. So we have a false or never true, we have an always true, and we have a sometimes true like the problem above that. Application problem. Table shows the average number of American Kennel Club registrations rounded to the nearest 100 for Burmese Mountain Dogs and Rottweilers. So we have this problem here, and this is about these different kinds of dogs, and gives a registration in 2006 and the average yearly change. Okay, so it says, if the trend continues, in which year will the number of registered Burmese Mountain Dogs be equal to or exceed or greater than the number of registered Rottweilers? So we need to know when the Burmese will be greater than or equal to the Rottweilers. So we need to look at equations for the Burmese and the Rottweilers. So the Burmese here has 3,700 to start with, and it changes 300 every year, and we don't know how many years this is going to happen. So 3,700 plus 300x, because we don't know how many years, or you could use y for years, is greater than or equal to the Rottweilers, which starts at 14,700 and adds negative 1,900 every year. So they lose 1,900 every year. So really this is a minus 1,900. Why? Because every year they lose 1,900 Rottweilers. So when are they going to be, when is the Burmese going to be greater than or equal to? Let's solve this equation. So the first thing I need to do is get all the x's on one side. So I'm going to add 1,900 to both sides. And when I do that, then I get 2,200 y is greater than or equal to, and we still have this plus 3,700 out here, so I'm going to minus the 3,700 from both sides. And so those canceled out, these canceled out. All I'm left with is 2,200 y is greater than or equal to, and so we do some subtraction, is 11,000. And then the last step, divide both sides by 2,200. So we can immediately cancel those off. We can divide both of these by 11. And so the top one will be 10 and the bottom one will be 2. And then we can divide both of them by 2. And so y has to be greater than or equal to 5. Well, what does that mean? That means in 5 years, the number of Burmese Mountain Dogs will be equal to or it will exceed the number of registered Rottweilers. So this is 5 years.